Okay, so here we are back for the second section. I hope most of you have managed to catch up with what we're doing. Okay, now let's get on with this. Remember, in the first section we looked at simultaneous equations by elimination. Now we need to do it by substitution. Well, substitution is what it says it is. We've got to find a way of substituting from one equation into the other. So if we take this equation first of all, okay, 3x minus 2y, 5x minus y. Our goal is to turn one equation into either a y equals or an x equals. Doesn't make a difference which term you use as the subject and which term you use as the object. Okay. In this case, I've rearranged the second equation to 5x minus 19 equals y. I've done that because in the second equation we've got 1y, and it means I won't then have any fractions to have to deal with later on. I substitute that into the equation, and then I multiply it out. Okay, notice to get minus 10x plus 38. Now continuing on from there, we get minus 7x, take that over to the other side, minus 28, so x is 4. Taking that 4 back into this equation, 5 4s are 20, take away 19, will give y as 1. Again, we can go back into this equation and just check it. 3 times 4 is 12, minus 2 times 1 is 10. As an extra example, we may get it into this form, where both are actually solved or put into the form of y equals. Well, the idea here is that if y equals 2x plus 10 and y equals 3x minus 20, then 2x plus 10 must equal 3x take 20. So I can put it into that form straight away. Then I need to solve. I'm going to take the 2x from here over to that side because this has a larger amount of x, and take the minus 20 over to that side. X is 30. If I put x is 30 back into this equation, I'll get 90 minus 20, okay, which gives me 70. If I put it into this equation, I can see I get 60 plus 10, which is 70. Now I've put them both into both equations, therefore I know I'm correct. Okay, and that's what you need to know really about solving simultaneous equations by substitution. The good thing about doing it by substitution now is that we can then move on further and look at non-linear simultaneous equations. These are like these, really. Things with squared or cubes in there. Generally speaking, we're going to be involved with looking at the squares. Now, some of you might have read ahead or learnt in year 11. You see the graph x squared plus y squared equals 25 would be the graph of a circle. If you want to try it out at home, you're more than welcome to. So, how are we going to solve this? Well, as I said, we're going to solve it by substitution. So what we need to do is to rearrange this so that either the x or y is on its own. So again, I've chosen this equation and I've chosen x because it's a single x. So I don't have to do any divisions, I won't get any fractions. So I get 15 minus 3y. As before in substitution, then I'm going to substitute into the non-linear equation. And this is where some of your algebra skills are going to be tested. What I suggest at this point is you pause this now, and then when you've tried it, see if you get the same answer that I got, and you know you're doing it well. Pause it. Pause it now. Okay, I hope you all paused that and didn't just let it play on so that you can have a look at the next section. Now, let's test your basic algebra skills. So we're going to multiply out this squared bracket, sum of the squares, so 3y all squared, 15 all squared. There's your 9y squared and 225, plus twice their product. Minus 3 times 15 is 45, times 2, 90. Rearrange it. Some more rearranging. More rearranging. And now I'm into a situation where I can factorize. Y is 4 or 5. Now we've got to find all the solution sets. Okay, so we can use this equation up here. When y equals 4, x must equal 3. And y equals 5, then x must equal 0. Remember, like in quadratic equations, we expect to get 2 answers. Now with non-linear, well, particularly with quadratic types of simultaneous equations, we also expect to get 2 answers. Sometimes one of them, like this one, really is called a trivial answer. Right? X is 0 is a trivial answer, sometimes. Okay, that's the simultaneous equations, and done by non-linear. Okay, so get back to your work. Hope that's been of some benefit to you. We look forward to seeing you next week.